27 divided by 3 is 9. 9 divided by 3 is 3. And what's 3 divided by 3? 1. So you guys need to realize that this is something you need to know. Anything to the 0 power is always going to be 1. And that's kind of why that is. Once we get to the quotient rule, I can also show you why that's the case, which is down there. So I'll show you another reason why in just a second as well. All right, the product rule. So what does product mean? What does product mean? What, Hannah? Multiply. So multiply. So the product rule is when you multiply two monomials together. So this just means there's no addition or subtraction. Together that have the same base, you add the exponent. So same base means that, this is your base here, means that the same variable or the same number is the base. The base must be the same. If you do not have the same base, then you do not have your, you may not add the exponents. But what the product rule is saying is that when you multiply, you keep the base the same and add the exponent. So keep the base the same. And add exponents. So let's talk about why you're going to be adding the exponents. So go ahead and write that down. So let's talk about why we will be adding the exponents. So why is that? So if I give you an example of x to the third times x to the fifth. What does x to the third literally mean? What does that mean? Yeah, it means list out x 3 times, right? So x times x times x. So what does x to the fifth mean? List it out 5 times. So our rule tells us that if we have the same base, which we do, they're both x, we can add the exponent. So 3 plus 5 should come out as how many? 3 plus 5. You're not multiplying, you're adding the... See, this is where it gets really confusing, because you see a multiplication symbol, so you want to multiply them, right? But you're really adding them. So this is why I'm showing you where it comes from. So we should get 8. How many x's do you see listed out there? If I did them right. 8. So it comes from the fact that you have 8 total listed out if you were to actually do the actual work for it. So that's why you're adding them, because there's a total of 8 x's total listed out. So that's why this is x to the 8th. Does that kind of make sense why you're adding the exponents when it's multiplication now? I'm trying to show you guys the reasons why. And you know what? If you can't remember the rules, listing stuff out is a great way to try to jog your memory about what the rule is. You don't have to maybe list out everything, but start listing it out and say, oh yeah, that means I have to add them. All right, quotient means to divide. So when you divide two monomials, remember monomials have no addition or subtraction, that have the same base, you subtract the exponents. So this is the base. M and N are the exponents. Notice we keep the base the same. And subtract the exponents. So, again, why is this the case? So if I do z to the 5th over z squared, technically it tells us that if we have the same base, which they're both z, we subtract our exponents. So we should get z to the 3rd power, right? So why is that? Well, how many z's do you have on top? How many z's do you have on bottom? 2. So if you have something on top and something on bottom, they can cancel. How many z's do you have remaining? 3. So now does that make sense why you're subtracting the exponents? Again, I'm trying to give you guys where things are coming from. I don't want to just throw rules at you guys and say, memorize them. You need to understand where it comes from so that if you ever forget, it's easy for you to go back and say, okay, I need to just list it out real quick to see what I have to do. Does that make sense? Okay, so this can actually go back up to the 0 rule too. So why is anything to the 0 power 1? Well, if I do like n to the 2nd over n to the 2nd, we subtract the exponents, right? So that is n to the 2nd minus n squared minus 2, right? Which is n to the 0 power, which should be 1. Does that make sense that that's 1? Isn't the same thing over the same thing always 1? So that's where that's another reason why anything to the 0 power is 1. So just giving you another look at why that's the case. Okay, finally the power rule. Power just means an exponent to another exponent. When a power is raised to another power, you multiply the exponents. So we're going to be multiplying the exponents here. So why is that? So if I do m to the 3rd squared, we know that m to the 3rd means we list out m 3 times, right? You guys agree with that? So if we're squaring something, that means we list it out twice. So 3 times 2 is 6, correct? How many do we have here? 6. So that's exactly why you multiply when you have that situation. All right. What questions do you have so far? And like I said, these aren't the only rules. We're going to be giving you a bunch of rules over the next 2 weeks, and that's why it gets really easy to jumble them. So I want you guys to be able to revert back to this listing out if you need to, and understanding of where they come from. So please ask questions now if you need anything. And whenever you're ready, you can flip to the next page. All right, so let's start with the product rule. So the product rule says when you multiply 2 monomials together, remember that means there's no addition or subtraction, that have the same base, meaning they have to be the same number or same letter. Yes, okay. And then you add the exponents. So even though there's multiplication in between, and Jenny, you did this earlier, which is completely normal, and I'm going to see this on some of your papers, even though they're multiplying and you want to multiply those exponents, you're really supposed to add them. And we talked about it's because you're listing them out, so you're just counting the number of x's that are there, or the number of y's that are there, or whatever it is that you're talking about. So let's start with the first example. With the first example there, we're going to start, I'm going to do a few of them with listing out. So that's x times x times x times x times x, right? Or that's x squared plus 3, right? That's the rule, it says to add them together. Either way, how many x's do you see there? 2 plus 3 is? Or you see 5 x's there. So you can do it either way. I want you guys to know that, but that gives you guys that kind of example of why that's the case. So I'm not going to list out some of these because there's huge numbers, but I want to give you that there. So what would I do then, Iris, for x to the 5th times x to the 12th? Yeah, we do not change our base. Our base stays the same, so we do 5 plus 12. And what's 5 plus 12? 17. Very good. Jacqueline, what do you think we're going to do with b squared times b to the 3rd times b to the 11th? So add every single exponent. The base stays b, and we do 2 plus 3 plus 11. So what do you get? 5 plus 11 is 16. Very good. So if you were to list those out, you would have 16 b's because you would have listed out 2 b's, then 3 b's, then 11 b's for a total of 16. Notice you're not multiplying them. If I list out 2, 3, and 11, I'm definitely not multiplying those together, right? So be very careful with that. Who thinks they know what we need to do on that last example there? Sarah? Yeah, so you have to multiply the numbers together first, right? And then you have like x to the 3rd times x to the 8th. So you're multiplying numbers together and then dealing with the things with like bases, essentially. So 2 times 5 is, and then what do we have to do with those x's? So we do 3 plus 8, right? So that is 10 times x to the 11th power. So we want to just kind of like adding like terms, right? Wait, you can't add an x and a y together. That's that same kind of concept with these exponent rules. You can only do things with like bases. So what questions do you guys have about the product rule? Make sure you have your notes out while you're doing your homework tonight. Don't forego using your notes. Otherwise, you're going to be making up your own rules. You're going to memorize them wrong, and then we're going to have to undo that just to redo the correct way. Okay? Don't make up your own rules. Quotient rule. When you divide two monomials, so two things that do not have addition or subtraction, that have the same base, you can subtract the exponents. So let's look at this first one again. I'm going to show you it with it listing out. Or what do you do when you divide? What does it tell you to do when you divide? Subtract. So it would be 10 minus 2. Let's just see if that gives you the same thing. So this cancels those two x's out, right? They become 1s. And I have 1, 2, 3, 4, 5, 6, 7, 8 remaining. What's 10 minus 2? 8. So either way, we get x to the 8th. So that's why that happens there. Spencer, how do you think we're going to do that second one there? 4x to the 17th times, or divided by 2x to the 4th. We'll subtract the exponents, okay. And what are you going to do with the other ones? The numbers. And we're going to actually just do 4 divided by 2, right? So 4 divided by 2 is what, Spencer? 2, and then what's 17 minus 4? Very good. All right, look at that slide and see if there's any questions you have on that one before we do the next slide. Okay. Power rule. When you raise a power to another power, you're going to multiply the exponents. So again, here are our examples. Again, I'm going to show you this one listed out as well, which is going to take a little bit, but that's okay. It's worth it so you guys understand where it's coming from. I know it seems like a lot of writing and stuff, but for your notes, it's good for you guys to see this, just so you know why the rule is the way it is. Okay, so if I were to count up the number of x's there, Vivian, how many would I have? 15. Does that make sense with what our rule says to do with our exponents? Is 3 times 5 15? So that makes sense that when you have a power to a power, you're multiplying. Because what you're saying is I have 3x's, like a group of 3x's, 5 times, right? That's what this is saying. A group of 3x's 5 times. A group of 3x's 5 times is 15. That's exactly what that is saying there. Okay, Jill. So how would I do x squared to the 10th power? What would I do?
You would multiply the 2 and 2.
And that gives you 20. Very good. All right, look at that and see what questions you have before we do the zero exponent rule. Anything to the 0 power is 1. So a to the 0 is 1. 2 to the 0 is 1. Anything to the 0 power is always 1. Okay? So go ahead and get that stuff written down, and then we're going to get into examples. We only have 2 more slides. And since you've seen the rules, I'm going to give you your test, okay?
Okay.
Because you were here Friday, right? Well, you were here yesterday, and I gave you the review, right? And then here's your screen, so you can put it on. Okay. Simplify using the correct exponent rule or expansion. It doesn't matter which one you want to do. If you guys need to expand, expand, okay? If you are somebody that is terrible with memorizing rules, use expansion. I know it's a lot of work, but it will get you the correct answer, okay? So I'm just going to go around the room. What rule is this one, Hannah? 0 power. And what does the 0 power rule tell us? Hannah, still you. I'm just going to keep talking to you for now. So anything to the 0 power is 1. So what's negative 7 to the 0 power? 1. Very good. Kaylin, what rule is number 2? 0. And what do you know about the 0 power rule, Kaylin? It's not multiplied by 0, it's raised to the 0 power, right? Because anything multiplied by 0 would be 0, right? So anything to the 0 power is 1. There you go. I think you meant that, but it's okay. I want to make sure we're saying things correctly. Okay, Vivian, what is the number 3? What property is that one? Or what rule is that one? And what does the product rule tell us to do? Add. So the product rule tells us to add. So what will I do there, Vivian? Good. All right, Jill. Number 4, what rule is that one? And what does the power rule tell us? So we're going to multiply. Very good. So what will you do with number 4? So what do I get? And notice our base has stayed the same the whole time. So don't forget that. All right, Katie. Number 5. What rule is that one?
The quotient rule.
And what does the quotient rule tell us? The quotient rule tells us to subtract. So I do what then? How do I, what am I subtracting?
You subtract the 3 from the 5.
Good. 5 minus 3 is 2, so that's x squared. Very good. Olivia, what rule is number 6? And what does the product rule tell us to do? Very good. So in this case, I'm going to rewrite it like this so that we can see the same pieces by each other. We also have some numbers in there. So what do we do with the 3 and the 2? We just multiply them. So 3 times 2 is? And what do we have to do with m to the 4th times m to the 5th? Yeah, so this is where it gets confusing because you're adding the exponents together, but then you're multiplying the numbers out front. But the numbers out front are coefficients. So coefficients are different than exponents. So just remember, coefficients we do the problem as is. Exponents we need to think about those rules. Alexis, what rule are we going to use for number 7? Quotient rule. Good. And what do you do with the quotient rule? You subtract. Is there anything you need to do with that 6? No, because there's nothing to divide it by. So what do we have to do with x to the 13th divided by x to the 5th? And what do you get when you do 13 minus 5? You're good. Yep. Okay, Jenny, what rule do I use for number 8? What do you do with the quotient rule? Now, we have like pieces here. Do I subtract j to the 6th and k to the 3rd? You do? Can you multiply j to the 6th and k to the 4th? No, they have to have the same base. So don't start combining things that are not the same. J's go with J's, and K's go with K's. You may not mix and match. Does that make sense? Okay, here. Jenny, do we have to do anything with that negative 4? No. So we have negative 4 times, what do I do with the J's? They will cancel out, but it's because you're doing 6 minus 6, so I just want to show that. But they will cancel out to become 1. They don't technically cancel out. They become 1. And then what do I do with k to the 4th divided by k to the 3rd? Good. So we get negative 4, j to the 0 power, k to the 1st. But we're not done simplifying this. Why aren't we done simplifying this? Kelly?
Because j to the 0 would just be 1.
So we actually have negative 4 times 1 times k to the 1st, right? Which is just negative 4k. All right. Look at that slide and see what questions you guys have for me there. Only have one more slide, and then I'm going to give you your other homework. I'll give you your homework and your other EOC to do. And then you guys can just work on your homework for the rest of the hour once you're done with your EOC. All right. Okay, how do you guys think we're going to do number 9? How do you guys think we're going to do number 9? Alex?
You take A and then you multiply 3 by 4 and you multiply 2 by 4.
Good. So what rule is this first before we move there?
Power.
It is the power rule. This is actually a power, like, there's multiple powers going on here, which we'll talk more about tomorrow, or Friday, I mean. But we do multiply. So as Alex said, what you're really doing here is you're giving this 4 to both the 3 and the 2. So this becomes a to the 3rd times 4 and b to the 2nd times 4. So Alex, what's my final answer then? So make sure we say to the 8th or a power of 8 or something like that, so we're not just saying a12 and b to the 8th, just to say it more accurately. So it's a to the 12th power times b to the 8th power, and that is what that is. And that makes sense, because if you think about this, what you're doing here is you have 3 a's listed out and 2 b's listed out, and you group that 4 separate times. So if I have 3 a's listed out 4 separate times, that's 12, right? If I have 2 a's listed out 4 separate times, that's 8. It's that whole grouping thing when you guys learn to multiply. I'm sure your teachers made you make little groups and like do things like when you were back in 3rd and 4th grade learning multiplication stuff. Or whatever grade they teach that in now, because it might be preschool at this point. I'm not really sure, because they just keep pushing things down. All right. So then what rule is number 10, Madison? Which one is it? Is there a power to another power? So there's a power on the outside here? No, they're multiplying. So which rule is that? This is the product rule. And what do we do with the product rule? You add. So I'm going to put like pieces together. So I have negative 7 times 4. C to the 3rd times C. What is C raised to, Madison? It has a first power on it, right? And then D to the 4th times D to the 3rd. So remember, you can only combine things with like bases. So the C's can only be combined and the D's can only be combined. So Madison, what are we going to do here? Yeah, so you're adding those, and then what are you doing? Yeah, and so you're not really doing D to the 4th plus D to the 3rd. You're doing D to the 4th plus 3 and C to the 3rd plus 1. Does that make sense? Because that would be a completely different thing if you were adding them. I knew what you were saying, but just to give you that too. So that's C to the 4th and then D to the 7th. Good. Jacob, what rule is number 11? Quotient. Glad that you know it starts with the Q at least. So what do you do with the quotient rule? You subtract the powers. It's really important though, remember what I said on the very first slide. You keep the base the same. We have never once changed our base, have we? So it's really easy when you get to numbers to start doing that. You guys will see that's 3 to the 13th and 3 to the 7th and want to make it 1. We do not change our bases, okay? So 3 to the 13th over 3 to the 7th, we can simplify that by doing what, Jacob? So what are you subtracting?
The powers.
Okay, and what is our base going to be still? We're still keeping our base 3. It does not become 1, and then we subtract the powers. So I do 13 minus 7. Is that 6? So 3 to the 6th power. What's 3 to the 6th power?
729.
729?
Can I use a computer to do this?
Yeah. I would use it. So that is 729. Very good. Okay, Spencer, what rule is number 12? Yeah, and what does the quotient rule tell us to do?
Subtract.
Okay, so we have y to the 3rd times z to the 9th over y times z squared. That y has an exponent of what?
3,
And the other one has an exponent of?
2.
No, the y. Do you think it doesn't have the same as the z? The z has the 2. What is the exponent on this bottom y? The denominator y?
0.
Not 0. It's 1. If nothing's there, it's 1. So don't forget that. So make sure you guys understand that that's a 1 there. So, Spencer, we subtract. So which ones are we subtracting?
Subtract y from y and z from z.
So y, so what numbers are you subtracting?
3 minus 1.
Okay, and then what are you doing with the z's?
9 minus 2.
Good. So we get y squared z to the 7th. All right, Morgan, what rule is number 13?
Product.
Yes, and what do we do with the product rule?
Negative.
What are you going to do with the exponents with the product rule?
We're going to separate them.
Yeah, we'll separate them, but what are you going to do with the exponents? Like, what will you do with m to the 4th and m to the 5th?
Add them.
You're going to add the exponents. Good. Okay, so you're right. We're going to separate those so that we know like pieces go with like pieces. Okay, so negative 3 times 2 is what, Morgan?
Negative 1.
You're not adding those. Those are actually multiplied. And this is where it gets confusing, right, guys? Because you're adding exponents and then multiplying the coefficients. So I understand why it's confusing. So I know why you got that. It's pretty normal. So actually multiply those. Negative 3 times 2.
1.
Multiply. You're adding.
Oh.
Negative 3 times 2.
Negative 6.
There you go. Okay. Now you add because they're exponents. So coefficients, you do as is, but the exponents, you're going to actually do that. So m to the 4th times m to the 5th is m to the
9.
Yeah, very good. And then n to the 2nd times n to the 3rd is
5.
good. So you're adding those together. You did that right. So that's negative 6, m to the 9th, n to the 5th. I understand where your guys' mistakes come from. It's very confusing. You want one of my computers
Need my test.
that you took yesterday?
Just look at it, guess.
Okay, just 1 minute and I'll bring it over there. 1 minute and then I'll bring it over there. Unless you're using a computer, Selena. You're fine. Samuel, I'll bring it over there in a second. All right. 10x squared y to the 12th minus 5y. What rule is this here? Just go back and I'll bring it over there in a second. So, Vivian, what rule is this? And what do you do with the quotient rule?
Divide 10 and negative 5 and get negative 2.
So you're actually going to divide the numbers. Good. And then what do you do with the exponents?
Subtract.
Okay. So, we're actually going to subtract. Does x have anything to subtract with? So y, you're doing 12 minus 1 because there's a 1 on that y. So you get negative 2 x squared y to the 11th. Al, what rule is number 15? What? It's not product rule. It's not power either. Look at what's on the outside.
0.
There you go. And what do we know about anything to the 0 power? Anything to the 0 power is 1. Do not multiply your bases. Do not change your bases. Your bases will always remain the same. So never ever change your bases. We do not change this. I'm going to see some of you guys put 4 here. We do not change our bases. We just add the exponents with the product rule. So that's going to be 2 to the 10th power. What's 2 to the 10th power? 1024. So please do not change your bases. If you guys even were to do this problem like just separately and do 2 to the 7th and then 2 to the 3rd and multiply them, you should get 1024 as well, just to check yourself as what you're doing. So do you guys have any questions here?